This is a question taken from JEE Advanced 2018, and the question is from calculus. So it has differentiation and integration involved in it, and we had to comment on the functions f and g given in the question. So let us go through the question. Before looking at the solution, I would recommend each one of you to pause the video and give this question a try. So that makes you understand the solution better when you have already given it a try. So you'll get the flavor of the question and you might see the approach and all. So yeah, I strongly recommend giving it a try before looking at the solution. So basically we have two functions f and g, both are non-constant differentiable functions and running from R to R. And there is an equation given in the question involving the differentials of this function and the functions. So this is the equation for all x belongs to real numbers. It is also given that f of 1 is equals to g of 2 is equal to 1. And we have to comment on f of 2 and g of 1. Okay, so let us consider this equation first. F dash of x, this is in the form a to the power m minus n. So that can be written like this: e to the power f of x by e to the power g of x times g dash of x. Bring all the f terms to one side and all the g terms to the other side. So that will give you e to the power minus f of x times f dash x is equals to e to the power minus g of x times g dash x. So you have the function and the derivative of the function on one side, so we can just integrate on both sides. So integrate this on both sides, e to the power minus f of x times f dash x dx is equals to e to the power minus g of x times g dash x times dx, plus there will be some constant c. So if f of x is equals to t, then f dash x dx is dt. And similarly for this integral, if g dash x is p, g dash x dx will be dp. So this integral will be e to the power minus t dt is equals to e to the power minus p dp plus c. So the integration of e to the power minus t is minus e to the power minus t. Similarly, minus e to the power minus p plus c. Take out the minus. E to the power minus t is equals to e to the minus c minus p. Here it will be minus c, but that is just a constant, so you can write plus c. So this is e to the power minus f of x is equals to e to the power minus g of x plus c. It is given in the question that f of 1 and g of 2 are 1. Of 1 is equals to g of 2 is equals to 1. So substitute x is equals to 1 in the above equation first. Then you'll get e to the power minus f of 1 is equals to e to the power minus g of 1 plus c. So f of 1 is 1. So this will be 1 by e minus g e to the power g of 1 is equals to c. So this is 1, and put x is equals to 2 in the above equation. So then we will get e to the power minus f of 2 is equal to e to the power minus g of 2 is also 1 plus c. So c is equals to e to the power minus f of 2 minus 1 by e. So this is 2. From 1 and 2 equate c. That will give you 1 by e minus e to the power minus g of 1 is equals to e to the power minus f of 2 minus 1 by e. So this will be 2 by e minus e to the power minus g of 1 is equals to e to the power minus f of 2. So if you see e to the power f of 2, it will be 1 by 2 by e minus e to the power minus g of 1. Now we have to comment on f of 2 and g of 1. We know that the graph of e power x looks something like this. So it is always positive. So e power f of 2 is always positive. So for e power f of 2 to be positive, this has to be positive. The numerator is already positive, so the denominator has to be positive. E power minus g of 1 greater than 0. So 2 by e greater than 1 by e power g of 1. So e power g of 1 greater than e by 2. So okay, sorry. So if we take the reciprocals, the sign will change. E by 2 less than e power g of 1. Take logarithm on both sides. Logarithm with respect to b. Sorry, with respect to e. Log e times e by 2 less than log e times e to the power g of 1. So this will be g of 1. This will be log e base e minus log 2 base e. So that means log 2 base e. So g of 1 is greater than 1 minus log 2 base e. G of 1 is greater than 1 minus log 2 base e. So that is option C. Option C. Now we have to comment on f of 2. Okay, we have to comment on f of 2. So let us go back to this equation. From this we can write e to the power minus g of 1 is equals to 2 by e minus e to the power minus f of 2. So e to the power g of 1 is equals to 1 by 2 by e minus e to the power minus f of 2. Correct? So by similar logic, even here we should have e to the power g of 1 always greater than 0. So for that to happen, the denominator has to be greater than 0. 2 by e minus e to the power minus f of 2 greater than 0. So follow the same steps and you'll end up getting f of 2 greater than 1 minus log 2 base e. So this is option B. This is option B.